I showed some pictures, but from those pictures, those data sets, we can have much more information on the environment. And that's what the most exciting thing about the DGT device.
Can you apply this for arsenium and
Arsenic?
also even for plug?
Yeah, sure. It depends on actually this device that I used a mixed binding layer, which means that I could obtain information on cations and anions. So I analyzed arsenic and a lot of different other elements. During my PhD, I did my research most on arsenic and using the DGT, but in another type of DGT. But it depends on your binding layer. If you have a binding layer that has affinity to a certain metal or different species of the same metal, I did arsenic speciation using DGT. You can modulate your binding gel to the element that you want to analyze or to that specific species that you want to analyze.
Do they use this technique in India to understand the mobilization of arsenium in shallow groundwater?
In India,
Yeah.
I think so. There are some works in India, in Bangladesh, especially. There's a very good group in Ireland that works with arsenic and DGT, emulating roots. This work was done there, and yes, there is a lot of work emulating rice roots. So it's a very interesting application of the DGT devices.
Any question? So thanks for all speakers for nice talks. And now we have a break. So we are a little bit on delay, so I will ask you to be fast, drink fast, and return back fast. Pelo Monteiro. She's a chemical engineer with a master degree in nuclear technology. Since 2010, she has managed the environmental monitoring program at the Instituto de Pesquisas Energéticas e Nucleares, IPEN, in São Paulo. She served as a consultant for the International Atomic Energy Agency on the isotope hydrology laboratory, specializing in 15 nitrogen and 18 oxygen of nitrate and deuterium and oxygen or 18 of meteoric waters. Since 2022, yes, her research group represents Brazil in a IEA project focused on stable isotopes in the extreme event precipitation events in here. Thank you, Lucilena, for coming. It's nice to have you.
Thank you, Professor. Thank you to Mesh for the invitation. Thanks for the organization. So, I'm very happy to be here. Thanks again for the invitation. And I will talk about stable isotopes in precipitation and the construction of local meteoric water lines, and I'll talk more about Brazil. As Professor Didier mentioned, my research group is integrating this CFP, this coordinate research project from the National Atomic Agency that involve all these countries, and we study convective rain events, and we are trying to assess the impact in some catchments. And I will talk more about local meteoric water line, and this, as you know, a regression line that involves the deuterium and O18 isotopes. It should be properly documented, usually express one monitoring station. It should be comparable to the global meteoric water line. And the International Atomic Agency recommendation is that it should aggregate at least 4 years of monthly data or 10 years of annual data for these stations. And this information, that information can be used in several applications: in geology, hydrology, forensics, medicine, biology, paleoclimatic studies, and food authentication and docking. So once you have this line construct, you can use this information in many other studies. And there is a knowledge gap regarding the proper documentation of the local meteoric water line. And please, I hope you all understand this well. It's not a criticism. It's not an exclusivity from Brazil. It happens all over the world. Outside Europe and US, there's this knowledge gap about the documentation of the local meteoric water line. So what I will try to show you is how we could correct that and work together to construct this line that can be used in many applications. So, as I mentioned, it's construction for a single station. There are some groups that assess this line for a region and propose a regional meteoric water line. I will show you some examples. Usually the slope will vary to climatic conditions, you will see the value of this slope regression changing. There are different methods for the mathematical assessment of this regression. Usually, in most cases, the ordinary least square regression is the case. However, it's not the best choice because the mathematical principle of this assessment is that the variables should be, one is independent, the other is dependable, and usually is not the case of the OET and the deuterium. So this major X is one better choice for the case when both variables are dependable. And you can also use precipitation weighted methods of linear regression. And what happens in that case is that ordinary least square regression usually treats all precipitation events the same. Doesn't matter the size of the precipitation event. And usually for those that study the charge of the aquifers, the small events will not reach the groundwater. So the precipitation weighted method can be more suitable for recharge studies. So pay attention to these. And during this coordinate research project, some of the discussions are related to the vocabulary, so local meteoric water line, regional, daily, monthly, because the regression line should aggregate all this information. If you refer to the local meteoric water line, the regression method, number of the events, number of years, which years, if it was sampled by event or monthly, all this information needs to be aggregated in the documentation of the local meteoric water line. So what can we do if we don't have 4 years for this assessment? Can we aggregate stations nearby? Can we use data from other researchers? These are some discussions that we are proposing with this research group. And I've brought for you some information, some lines that are documented in other studies. So here in this table, you have a general assessment of how this local meteoric water line should be expressed. So you have the temporal resolution, how it was built, the regression mode, the temporal coverage, so the years that you collected, the number of points, the equation itself with the standard errors, because without the standard errors, you cannot compare these lines, the regression coefficient, the spatial coverage where these points were sampled, and the reference that makes this documentation. So here you have the Lozansky document that is the cornerstone of this work sometimes. There's a nice reference from Australia and a recent publication that was done in Cuba that makes this proper documentation and can be used as an example for the local meteoric water. So this research paper explains how these different regression methods can be used and when each method is recommended. And what you see here is that the rainfall, the size of the rainfall in these places could affect the regression you observe from one side or the other. So in Alice Spring, you don't see difference in the size of the event. But in Perth, if you select only events larger than 20 millimeters, you could have a totally different regression line. And this can affect the equation you should use to compare in recharge studies. you need to pay attention to this if that is the intention. This is a very recent paper from Garcia Moya from Cuba, and it's a data descriptor that describes all the isotopic information in Cuba. So for these studies in this island, you have that many stations and regression lines, both methods. There is no statistic difference between these two, but we should assess anyway, because it could be the case that for your station, for your location, there is this difference. If you don't assess this, you don't know if there is or not a statistical difference between the regression lines. And this is another paper from Hatvani, that's a Polona integrated group, and they discussed the regional meteoric waterline in the Mediterranean region. And as you see here, they have quite a long monitoring coverage, but they decide to work in the more recent years. And this increase in the number of points is strongly correlated with the laser spectrometry. This increase was done because of the Picaro instruments that made more accessible, more easy to measure. And what about Brazil? What we have here? So I was able to find a couple of studies from Professor Didier and this reference, here from GIAS that properly assessed the regression line, but as far as I noticed, it was only 1 year coverage. That was discussed inside the CRP because it happens in almost every country. Is the time of a master of a PhD program. So it's very difficult to have this 4-year assessment. Once that is done inside university research institutes, and you have to publish the data. So the coverage of 4 years is the main problem, and we need to pay attention to this. So this CRP is currently working in these recommendations and how to assess this meteoric waterline. And we will present the study case of Brazil, will be soon submitted. And what is our situation? The geographical coverage that we have in the 60s, 70, 80, and 90 was pretty much better than we have at the moment. So besides the Horizonte, all the other information we have are here in São Paulo. We are eager, waiting for the data from Roberto and Isadora. And what you see here is a collection of data from all these publications, mostly from GENIC, it's the blue data here, but from some publications listed here, papers, theses, and works in the academia. And what we have is 51 stations, data from 1961 to 2024. That's the coverage, and that's the information we have about precipitation amounts. So less than 20% of all data, of isotopic data, comes together with precipitation amounts. So that's the coverage we have for precipitation weighted regression to assess the local meteoric waterline. And these are the papers we were able to assess in the great city of Araraquara, Belo Horizonte, Rio Claro, São Francisco Xavier, in São Paulo, and from this data in São Paulo, we have data from IPEM. And we compare the regression methods, and that variability was most of the time small, except in some years like 2015, that it was a El Niño year. And 2019 here in Rio Claro, and here in São Francisco Xavier in 2020. So we are still investigating why. It's interesting that that was observed mostly in those cases. And the source of variability in the slope and the intercept, as you all can imagine, was largely spatial. So these are three cities that were monitored in the same period of time that present a larger variability. But here in Araraquara, we have 5 years and we still see significant variability. And that's the main reason why the recommendation still keeps for a minimum of 4 years of monitoring. And do we really need a minimum of 4 years? And here I show you, we have data from São Paulo 2022, 23, and 24. And these are the trajectories with the deuterium excess, the precipitation amount, the O18, and the so 2022 and 2023 were pretty much the same. But as you can see, 2024 was totally changed. And the intention to use this 4-year coverage is to avoid that one odd year like this could affect the whole regression. And what about the spatial coverage? Because the paper I show you in the Mediterranean area try to access spatial coverage to decide how far this local meteoric water line can be used. What is the area this line can be applied? And in the Mediterranean area, they decided 10 kilometers was enough that they could replace or use data from one station to another. But Brazil is, I think it's too big for only 10 kilometers. And as you see here, we got more recent data and available here. And we try to assess how this spatial coverage could be aggregated in case of one of these stations need to stop or complement the data. And we use cluster analysis. We have this ratio of deuterium and O18 as a variable. Deuterium alone, O18 alone, and the geographical latitude and longitude variables. And the cluster that we tried at the moment, we still need some sensitivity analysis, but the aggregation we had was like this. São Paulo, São Francisco Xavier, Bragança Paulista, and Campinas together with the first cluster. Santa Maria, Piracicaba, Araraquara, Rio Claro, and Brotas together. So in case of any of you could use this data or required to use this data, we could, for instance, aggregate these 5 cities and these 4 cities together. Could be done in spite of being apart more than 10 kilometers. And this coverage, you see here the regression lines, and they agree. There's no statistical difference between the individual regression lines of each of these cities and together. And now we will try some assessment of the temporal coverage. Because as you see, this could be coincidence about the data, because we don't have the same temporal coverage. And now we will investigate more the temporal coverage to see the periods that we have data from the same cities if they still remain. It's a lot of work to assure the local meteoric water line is, while we could only collect the data and analyze it and make this available for the whole community to use in all those applications that I stated before. So the final consideration is that we don't have enough structured data available for we all together to work. We need more data. And there is this call that countries and governments should aim to keep long-term records, to join and promote initiatives like GNIF to have to host these data. And I think we all could think about to have these hosted as a Brazilian group or something. It will stay longer than all of us and it should stay longer than all of us. And the local meteoric water line is a reliable tool, but it requires a lot of effort, appropriate temporal coverage, and data treatment. So we have here already publications that indicate that if not properly assessed, you could have bias in the recharge studies. And we need to work more and improve this because local meteoric water line is the basics of all what we will do in isotopic studies, water isotopes. So I'd like to thank the CRP group that is working together, the University of Costa Rica and the CBTN in Belo Horizonte that they are working with us. Thank you.
So we have time for one quick question. Not for you, but
If you have more questions.
I would like, yes.
Okay. Okay. I have one question, but actually it's two, but it's in one question. So I lost the information, I think, but when I have less than 4 years of data, what method you mentioned to produce the line? And the second one is like, do you have any guess of about the kilometers here in São Paulo that like the Mediterranean region that is 10 kilometers? Do you have any guess for here in this region?
So what you should do if you have less than 4 years of data. Describe as a reference line, a year line or a 2-year line for your area, but it should not be used as a local meteoric water line. It should be like a isotopic reference meteoric line, because for you to have an idea, I saw some papers that had 6 precipitation samples and used these as a local meteoric water line. So the message of this presentation is please be precise about what you call local meteoric water line and state all the features of a local meteoric water line. You can use these 6 samples, no problem, but it's only a regression line. And anyway, you should state the regression method, the location of your station, the data, the seasonality, the year that you sample, and all these features. It does not prevent you to work with this 1-year data. It's a lot of work. It's in the Amazon is a lot of samples that you have to process, a lot of data, but it should be a reference for your work and local meteoric water line itself. Regarding the spatial coverage, you can see in the books and in the papers that usually 1,000 kilometers in latitude, you have 1 per mil change. It's a lot. I don't think we have the ability to have 1,000 kilometers difference and still use the same meteoric water line. But like something like 100 kilometers, 200 kilometers could be feasible, could be done. But we are still working on this to provide you with a better number.
Thank you, Luciana. I have a lot of questions and some points to discuss with you, but maybe do you stay here?
Yes.
Oh, that's good. So I would like to invite someone that I I didn't see, but I realized that she's here. Professora Ana Elisa Silva de Abreu. She's from Unicamp, and she holds a geology degree from University of São Paulo and has a civil engineer degree from Mackenzie from 1995 to 2005. She worked as a practitioner in engineering geology and the environment in 2005. She started her academic career and got her master and her PhD in USP. Since 2016, she is a professor at Unicamp, responsible for the subject of hydrogeology and engineering geology. Her current research interests in hydrogeology are the use of hard earth elements, concentrations in groundwater to understand aquifer connections and eco-contamination and the refinement of hydrogeological conceptual models aiming to have water security. Thank yeah, some words, tricky words. Thank you.
Thank you, Didier, and I would like to thank the whole group who's organizing this symposium. It's very interesting, and thank you for inviting us from Unicamp to be here. So the title we gave to this presentation is Hydrogeological Conceptual Model of Crystalline Via Basin Tubarão Aquifers Contact Area in Campinas, São Paulo. I joined the group in 2016. These are my colleagues, Sueli and Jacinta. They have been working in this area before me. And Thais is she is a PhD already, but she was the student who did all the work, and we just told her what to do. Yeah? And now she works at Water Services and Technologies in Belo Horizonte. So I'm going to present mostly her results. We have published our results in these two papers, and I will first show our most important conclusions, and then I will move on to things that we didn't really explore in these papers, so there's some new material here. I'm showing you our beautiful university. This is a picture of Unicamp. This is the Geosciences Institute, and here the red circles, they are location of the wells that we have, the tubular wells that we have at Unicamp. So it's a privilege, in fact, to have so many wells nearby. And these ones that don't have a name, we also don't have a pump, but we use them. We did video survey and logging, geophysical logging of them. And these are the ones that have names on them, that have tags on them. They are the ones that have the pumps and that actually provide water for the university. And you see here, oh, I didn't put a scale here, but I want to tell you that, for instance, these two wells, they lie 100 meters apart from each other. So they're really, really close to one another. These two, for instance, they lie about 300 meters apart from one another. And maybe here we have 500, 600 meters. So it's really, really a small area. But it is a difficult area because it's exactly in the contact area of Tubarão, the basement, and the Adia base seal. So we have 3 different aquifers in the same small area. It was an opportunity to try to understand some of the things that are going on there. So the things that really caught our attention is the fact that only this well has anomalous concentrations of uranium. it constantly shows uranium concentrations above the radiation limits. So this has never been a problem in terms of health because all these four wells they provide water for a big reservoir that lies under this square. So we have division of this high uranium concentration. But anyway, the question was from the beginning, how can this well have such high concentrations and the other ones that are so near to it, why don't they have uranium concentrations? And also it was kind of freaky to hear inside the university, there was always someone who would come up and say, oh, it's probably the physics institute. They did something wrong in their labs and they are providing the uranium for the well. We get that a lot. Yeah? So our group started working also to make an effort to prove that it's geogenic and not anthropogenic. At least this was our hypothesis. Yeah? And I think that we are convinced that it's not anthropogenic. Anyway, I will first show you our main conclusions, and then I will focus on what we did in this GMU well. So we did a lot of things, especially from 2019 onwards, when we got money from PESP. Then we had the chance to do all the things that we wanted to do before. So we did borehole video survey for all the wells, acoustic borehole imaging for not all the wells, but most of them. Heat pulse, this now goes only for GMU, that well that has the highest uranium concentrations. So we use heat pulse flow meter, and we did some hydraulic and hydrodynamic tests with Parkers. And we sampled all the wells. We collected open hole samples. And we also collected discrete samples with the Parkers from the GMU well. And with the samples that we collected, we did hydrogeochemistry, of course, physicochemical parameters in situ, normal hydrogeochemistry, that's here, where is that? Ion chromatography, major ions, and then as we have the ICP-MS, and we have a very good, very skilled technician there, Margaretti. She really does magic with this ICP-MS. So we can also have these minor and trace elements from the groundwater. And we also collected samples for stable isotopes determinations, and for tritium dating and carbon-14 dating. So we did all this, and what we concluded after we analyzed all the results is that before we started using this groundwater in the area, this was probably the situation. Oh, I was confused. Yeah, there. Before we had the boreholes, before we had the wells, this was probably the situation. We had phreatic aquifer here, confined to the soil layer, and then maybe or probably the diabase seal here prevent this water from going down. And here in gray you have the tubarão aquifer, which was probably a local, was probably a phreatic aquifer too. And here in the crystalline rocks, we had a confined or semi-confined aquifer with upward flux, and it was delivering older water. And here in this area, it was probably already a discharge area of this old water. And after we constructed the wells and started using the water for the population there, we changed the system. And nowadays, what we have there, it also depends on how the wells were constructed, were built. But what we have there is that one of the wells gives us modern water. This is this well, IBZ, because it has filters in this area. So here we're really using modern water. And here in this area, in this well, we have various ages. We have modern water and old water, the mixture. Here in this well, which is our focus, I will talk about it later on. We also have a mixture of old water and new water. And here at Fifth well, we have mainly old water, and the flux is upward. Um, the specific capacity of this well is really, really good. You have a good yield, but you have practically no lowering of the water table. So this is what we concluded from all that we did. And today I want to show you something else about the GNU well, what we, well, the experience that we had with the stable isotopes here. So this is the log for the GNU well. You have here, let me see where I start. Well, we have here the information from the geophysics logging, the acoustic borehole logging also, and from this information we interpreted the fractures, the structures that were crossed by the well. So here, this row is the interpretation of the structures. Here you have the results of the heat pulse flow meter, which shows that the flux is upward. And here we have the positions where we placed the packers. So this packer investigation was performed only in this well, not in all the wells, because I do recognize that, well, no, let me phrase it another way. Here, if you look at this column, these are the structures that the borehole, that the well crosses. So we can see that there is a concentration of structures here, and then another concentration of structures here, another concentration of fractures, and then there are fractures at the bottom of the well. And I admit that Swilly and we always thought that these fractions at the bottom were responsible for the anomalous running concentrations. Because we said, wow, it's probably from the old water, and I don't know, we just thought that this was how it worked then. But so we use the Packers. This is the drawing to represent the Packers. So we collected a sample from here, from the bottom of the well, and then from these fractures, from these discrete interval here. And we also tested this upper part of the well, all these fractures together. And for this part, we found out that there was no water coming in the borehole, in the well. So the only active fractures were really down here in these three intervals. And here, all this up part here, it wasn't delivering water to the wells at all. And we also collected, but then on a different date, we also collected an open borehole sample. And this was done with the pump from the well, okay? And here you have already some of our results. You have the numbers, I will show you also a graph in a few slides, but you have the numbers for delta deuterium and delta oxygen. You have the numbers for tritium, for carbon 14, and then here the estimated age from carbon 14 determinations. And what you can see here already is that the open borehole sample has an average age of 2,500 years. And the various fractures here, fracture zones here, they deliver water with different ages. Some of them are older than 2,500, and there's one here at the bottom that is younger than 2,500. So with these results, we thought, well, let's estimate the mixture then. Let's just use the stable isotopes and estimate the mixture. And this is what comes next. I modified this from the data that is published in the articles because I wanted to emphasize this thing about the mixture. So I erased some of the data for the other wells, and I'm showing you only the data for this specific well. And what we can see here is that this is the open hole sample result, and these are the other results for the various different depths or various different intervals that provide water for the well. And we can see here that it's not possible to estimate a mixture from this data because, well, this point is clearly out of the group. No? So we were wondering, and we still wonder what happened. No? A friend of mine, Luciana, she was here, she left for San Jose because they had traveled for, I don't know, 3 or 4 hours. But the first thing that she said, you probably did something wrong with the sample collection. But then she said, well, we really hope we didn't. And Veridiana showed also the problems the small problems that we can have. She said, well, we still hope we didn't have this kind of problem. We don't know. At least we didn't get any information from the lab about this. But we really hope we did everything right. And then the question is, what could explain this kind of situation? Because you have these discrete samples, and we hoped that they could just give us a number of the proportion, allow us to estimate the mixture. Then this doesn't work. Then one thing that came to our mind, or that you consider, is that this could be related to the way that we do the sampling. I mean the following. This is the situation when we collect the water for the discrete samples. So we have the packers in place, and we use a small pump to collect the water, to purge the water, and then to collect the water for this small interval, 3 meters interval. So the yield here is small, 7 to 11 liters per minute. This is one situation. And when we collect the open hole sample, we use the pump from the well. It's back in place. Oh, of course. It's in this situation that when we do this job, these things have been removed, the pump has been removed so that we can put the packer inside the well. Okay. Then we put back the pump and we let it work for a few days, and then we collected the open hole sample. So this is the situation when we collect the open hole sample, and here this photo is just to give you an idea of the yield of the well when we collect the open hole sample. So it's about 150 liters per minute. So this is one of the things that we think about. Maybe when we collected the discrete samples, the volume of the aquifer that we were mobilizing was much, much smaller than the volume of the aquifer that we mobilized when we collected the open hole sample. And this might explain this problem that we had. So we still believe that this might be the case. Okay? And the second thing that I want to show you that is not so clear in the articles because this was not the focus. It's something that we presented in a poster in our Congress. Yeah, that's it. These results, let me just tell you what we did. Right in the beginning of the research, we had doubts about how long should we keep the pump running to start collecting the sample. Some people say, oh, you just purge the water, 3 volumes of water, and it's all right. You just wait until you have the dynamic level stabilized and then go on and collect your sample. But I don't know, we read so many things and there were other propositions also, so we said, well, let's check. And Thais did this. She did 48 hours. Oh, it's too small here, but I'll tell you that. Here you have 48 hours. We started the this well is usually nowadays it's shut down and they don't use it anymore, and they only turn it on when they need to do some sampling there. So when Thais wants to grab a sample, people who work for Unicamp, they turn on the pump and they let it run for 3 days consecutively, and Thais collected the water on the third day usually. So what she did was at 10 in the morning, they turned on the pump and she started collecting samples. That's here, that's 10, 15, 11, 40, 12, 16, yeah, 7 p.m., I don't know, and so on. So this is one day, second day, and then there's one sample on, yeah, first day, second day, on the third day before she really collected her sample. And this here that I'm showing you, this is the electrical conductivity of the water. So here you can see that after when the dynamic water level stabilizes, this red line. Well, no, that's true. We could collect our sample because the electrical conductivity was already stabilized, okay? And the temperature, well, that's not really that easy because when the dynamic water level was stabilized, the temperature seemed to be stable, but then on the second day it changed. It went to another level. Here you have 25.5 degrees centigrade, and here you have 27 degrees centigrade. So it's a difference. And here for the uranium concentration, well, is it stable, isn't it? It really depends on how you open this scale. Anyway, what we see here, the way we interpret these results is that, especially from the temperature change here, maybe what happens at Unicamp is that nowadays they have 3 working wells, and GenU is in the middle of all of them, and they turn one of them on one day, and then on the next day they turn another one on, and the first one is not working, and then on the third day the third well works. So they change the well that works each day. It's not always the same configuration in the system. The configuration of the system changes. Because on each day they have one well working around GNU. Okay? So, one way of interpreting this is that maybe when you have another well working around the well that we are studying, the circulation changes in the aquifer. And this could explain our results for delta 018. Hang on. I hope this was not too complicated. I hope you got what I mean. And in fact, about these stable isotopes and our effort to estimate the mixture, that was it. We just didn't do the calculations, and we still don't know the answer why that happened. Okay, I just showed you 2 of our hypotheses. And then I'll change the subject and show you some of the hydrochemistry of the water. So these results are extracted from Thais' thesis, but Isabella, the young lady that is sitting there, she had reached some similar results in her graduation during her undergraduate studies in 2015. So from the paper, we can see that, especially here, GMU and FEF, the two wells that are really near to each other, they kind of form a group here in this area. And IBZ and IMEC, the other ones, the two wells that deliver modern water, they group here. They are the green and the red colors here. So this is something that we knew before we got the money from FAPESP. Then with the money from FAPESP, we moved on and explored lithium concentration in these waters and lithium isotopes, delta lithium 8 in these waters. All these are, let's say, preliminary results. But here, for instance, from lithium concentrations, there is a suggestion that the same grouping that we see here at Piper, of course, occurs here in the wells. And we interpreted that this is probably related to the evolution of the water in this system with three different aquifers. And here we have a correlation of delta lithium and apparent age. And well, we could maybe estimate a line here, but we're not sure yet. So I do that a lot, you know, instead of bringing answers, I bring my doubts and maybe someone helps me find a way to all this, okay? We would like to thank all our sponsors. We got money from many different funding agencies and, of course, Prefeitura da Cidade Universitária. They're always helping us with everything that we need. And I'd like to thank you for your attention.
Thank you, Anna. A nice talk. Good to bring some questions. We're still doing research. Questions? We have time for one quick question. No, I don't have questions. Because I have.
You made all of them during the times.
Yeah.
Okay, thank you.
Well, we have some ideas.
Yeah, we have some ideas.
Or then you can tell that later.
Yes. Yeah, later. Yes. So to finish our day, I don't know who come. Unfortunately, Vladimir is expected to be here today, but he has some health problems in his family, and he is not able to come. So we come for the last presentation of the day. We are a little bit on delay, but not too much considering Brazilian. We are in Brazil, so I guess it's important to say something about the last presentation because Lucilene mentioned something about some national effort to create isotopic database on precipitation, on river, on groundwater, and I think that the main player in this case is the geological survey from Brazil. I guess they have all the knowledge, they have people, and they are installed in our country. So it is important to finish this workshop talking about, right, it's an overview of the National Program for Isotope Application in Hydrology. I don't know who. Oh, who? He or she?
We go, we did
So
it
it's,
together,
it's
but-
like geography.
Geography.
Yeah. Okay. One
Like
friend.
in the press group.
Yeah. Okay. Nice. So I already presented Isadora. Roberto is also a geologist. He's a good friend of mine, and he did. Don't get his PhD here at the university at UNESP, and always it's good to work with both of you guys. So, who will start?
We are going to do this Jogral type.
Yes.
Okay. It's Jogral gaúcho. Bate, rapaz!
So I will do very quick words. So to while Isabella prepares the slides. In 2015, we were called by the agency, or in fact, the agency called UNESP to be offered UNESP to be the center, kind of collaborative center for the diffusion of isotope hydrology in Brazil, and that was understood from professors here at UNESP, Professor Didier and Professor Shank, that this was something that would be benefit to a geological survey. So then we were called by the agency to start this kind of problem. On that time, it was very hard in terms of the political scenario within our company. And in fact, they didn't want to, they didn't understand what was the main objective of this isotope problem. But we started from the fabric floor. So the technicians realized that this was very important, despite the understanding of our high-level managers. So we started that from the fabric level, and then we began to build a kind of program for isotopic applications in hydrology for the entire country. The first GENIC device was borrowed by Didier, and it was taken, yes, yes, and it was taken by myself to Porto Alegre, where it's my hometown, where I had friends inside the geological survey. We had a boycott not to do it, and we did it anyway. So then among friends, we installed the first GENIC station, this kind of GENIC like you see with this wonderful presentation. So this is a small story just to tell you how things and how research in Brazil sometimes start by the willing and by the understanding of very good technicians, just like you guys here are. And this is, I love this story because it tells a lot. And then we installed this first GENIC, and I took lots of pictures. And then a couple of months later, there was the World Cup for isotopes in Vienna at the agency. And then in the main portal of this very nice building of United Nations, there was a world map with pictures from GENICs all over the world. And that GENIC from Porto Alegre was there. So like saying, look, we care for this, and the community, the international community is looking for this data in Brazil, just like Lucy just showed you, that we had this decline of GENIC during the 90s. So then the whole idea was to re-inaugurate this GENIC system in Brazil, plus some other techniques for groundwater dating and so far. And by saying that, we have also to recognize those that did the whole work with GENIC before that re-inauguration. The GENIC in São Paulo, the GENIC in Araraquara and Required, and GENIC in Belo Horizonte, they were like the Don Quixotes for the GENIC, because they were keep doing it without so much support under the government level. So that was the start of this program, and by now we are in 2025, where Isadora then is going to show you what
what was achieved during this whole period. So the story of under the boycott, stalling the Geneve, and then, okay, it started with one, so now we have almost 30 all over the country. And we are about to show the data and to show the community, like, to come up with a very nice inauguration of the Geneve where everybody is allowed to contribute some Geneves that are for research and, well, can start.
Thank you, Roberto. Well, when Roberto, just to say tell my side from the story, seeing Roberto starting all this movement, he was already here in São Paulo, I was there in Porto Alegre. But I, as a geology student, I was already working on isotopes. I always really liked the subject, and I was working on the monitoring network, and seeing Roberto doing all this movement, I said, okay, I will click on him. And then now we are together here presenting to you. So it wants to be acknowledged for all the efforts Roberto has done for this program. So the objectives of the program, we have very clear these for us, and we always talk about it between us when we need to take any kind of decision. Is that we want to apply and disseminate the use of isotopic tools. So we really want to give support and facilitate the isotope initiatives both in Brazil and Latin American countries. So we want to promote national and regional cooperation, capacity building, expansion of analytical capabilities, and is to reach better sustainable development on water resources. So, as Roberto just said about this story, this is the famous picture of Genip there, and these are both technicians that work for the river monitoring network. So we are working in this way nowadays in the survey. I'm the only dedicated researcher that I'm full-time working for the isotope program, and all other colleagues and partners that are supporting the program, they just do it because they like the program and they want to join and they see the importance of the use of the isotopes in hydrology. So nowadays we have 24 active stations, and we are going to install 3 new stations in 2025. And this is interesting, good to see that we work with partnership with many different institutions, and it's our job, our task to publish the first reports on this data that already have some years, and all these things with logistic and analytic support from the IAEA. They analyze all the samples for us. Well, besides the GNIP, we have enrolled in some coordinate research projects from the IAEA. One of them is the use of long-lived radionuclides for dating very old groundwaters. The first deliver from this CRP, from the survey side, was Roberto's PhD thesis. So he applied noble gas for the whole Guarani aquifer system, and I kind of continue his work with this focus on the southern area. And the objective is to enhance knowledge on the site groundwater ages. And we have working on this project currently me, Roberto, and another researcher here from São Paulo. We have collected a lot of noble gas data. We just went for the field with researcher from Argentina with the gas extractor to collect samples for 81 krypton. So it's still going on, but it might finish it to the end of this year or the next year. We also have this, we're enrolled also in this CRP that's coordinated by Lucy Ortega. That's isotopic assessment of the impact of climatic and meteorological changes on wetland and groundwater ecosystem. It's a case study in the CRP river watershed. Didier is with us also in this CRP. These are other colleagues that are participating of the project. And we are using on-site radon analysis to understand this connection between the wetland and try to understand better characterize the functioning of the hydrological system there. Kind of as a continuity of this first CRP I presented before about the long lived graded sites and the Guarani, we started last year this project on integration of groundwater ages with numerical models. So here is the Krypton structure that was brought from Argentina to do the sampling. PDA is also enrolled in this project with us.
Not too much.
A bit far, but yes. Yeah, the idea is to develop a methodology or a proposal on how to incorporate groundwater ages on numerical models. So the objective is to translate more efficiently the data from the long-range nuclides in useful tools for groundwater management. Currently, there is a student, a PhD student that's joining us. He's from Universidade Federal de Pelotas, and he will be dedicated to develop the numerical model. We also were enrolled in the CRP from the GENIR, from the Global Network of Isotopes in River. We are still kind of on baby steps on this because it's quite challenging to sample in some river systems. But we have some already 2 season sample campaigns on the San Francisco and Coxim Taquarini rivers, and we are eager to do the Amazonas. But yeah, it's kind of challenging. So, we have analytical support from the CEA UNES and Texas University, and we are looking forward to present some data at COP30 this year. Well, we also got a technical cooperation project, also with support of the IAEA. And the main objective of this project is to generate groundwater age data from 3 different aquifers in Brazil in the northeast area. But the idea is the main goal of this project would be the acquisition of this portable mass spectrometer for gas analysis, the mini-ready that we mentioned before. And it's about to be delivered. So we are very excited because the usefulness of this equipment is super wide. So we can get really creative on the applications, both for age estimation, but also for processes and mechanisms on recharge and flow mechanisms. We are going to have 3 research fellowships to improve the knowledge of the researchers from the survey on the use of this data. And we already had 3 scientific visits, 2 scientific visits that from experts from another countries to support us on our initiative that is operated. Well, about the analytical capabilities, we just installed, about 1 year ago, more or less, our first laser analyzer for stable water isotopes. It's an LGR, and it's installed in the LAMIN, that's the water laboratory analysis network from the survey. It's in Caetém, Minas Gerais. And we have lab analyst, that's Magda, this young woman there, that she is working on her PhD as well on mineral waters, and she is implementing the use of these equipment within the survey. We are having some troubles, some issues, but we are confident that we're going to get it. So we just had this expert mission from an expert from Argentina. Mauricio Quiroz came to give this training on the limbs and evaluate the situation of the equipment and all this thing. And this also with support of the IAEA. And we are looking forward to participate on the global network on water analysis laboratory from the GLOAL, also an IAEA initiative. And we want to say that to become a reference and promote national laboratory intercomparison, because we see that nowadays we have many laboratories that are able in Brazil to do stable water analysis, but we are not very good inter-laboratory comparison. So our idea is to start to promote this kind of exchange within Brazil and also within Latin America. Also the exchange on the standards, we are already having very good conversation and exchanges with USP and here in Aspen, and Magda is learning a lot from you. So about capacity building, within these last 2 years, we had some researchers at the agency being trained both on noble gas applications, but also hydrochemistry, modeling, and these on-site equipments. I was there at the agency for 1 year in an internship, and we are also promoting these cooperation with promoting, facilitating, and participating in this regional cooperation. We just met in Uruguay last year, so it's been very fruitful, I think, these exchanges with our neighbors. Here, a little bit about the cooperation. Here is Roberto presenting on the talk last year. We had a dedicated session for the Guarani Aquifer system that was organized by the Geological Survey, by Roberto mostly, and it was a very important participation there. But within these partnerships and our work there, the PhD, we are developing. Roberto just finished, and I'm going to finish this year. We have been able to publish some, but we are very few working on it. So we do the field work, we do the management, we do all the process of the whole project. So it's quite challenging to really focus and get papers published in international peer-reviewed papers, journals. But we are doing this through supporting our partners' institutions. So as I just mentioned, there is a new student from Pelotas, there is a student from the DA that we can support sometimes. So we are super open to discuss and to establish this kind of partnerships. Well, the next steps, we just forgot to say that we are a collaborative center. So we are a collaborative center from the IAA. That's why we have all these. The IAA has this importance on our work as on the isotope program. So the collaborative center on isotopic application in hydrology, and so this is really our task, to promote this kind of things, partnerships, and support activities. So we need to work on the designation as a collaborative center. We are going to conclude to include this wetland CRP. We are participating on the country program framework elaboration for the next 4 years with the name. It's really important because it's the first time where the hydrology and the water systems, they are really getting to this discussion within the National Commission of Atomic Energy. We have 2 PhD theses to be concluded. And we are looking forward to build a new project, a new regional project then with our partners. We are still designing this idea. This year we are going to receive the minority, the 2 RAD8 for radon analysis. So, and yeah, that's it. Thank you.
Thank you, Isa. Questions?
Yeah,
Oh, you don't have a question.
no,
I
just
have a comment.
well, and I have a gift for you.
Oh, that's good. Okay.
Your comment first.
No, my comment is about when everyone used to do this, when you mentioned the ODS, the Sustainable Development Goals. The first idea is to put the number 6. So it's water. But we are not talking about water. We are talking about smart cities. We are talking about sustainable society. We are talking about most of the 17 goals. So I guess we have to keep this in mind when we present something about isotopes and about water. So Celso mentioned something about the importance of water and the importance of to build our capacity to improve our knowledge about water availability or water movement or the sustainability of our country. So isotopes can provide this, and I think all the examples show it here. We have a lot of applications and we have a lot of very good groups. Maybe some of them were not here, but for the next workshop, I would like to have people from other parts of the country, like Brasilia, like Pará, Bahia, Ceará. So we have a very good scientific group.
No, just I think it's very important what you said, yes, and we have to realize that really to keep this message and working with isotopes in Brazil, we have really to work together with others. So I think this is the whole and the very strong message that sometimes it starts with a seminar just like this, so that people get to know each other, so that the guys from Unicamp knows that there are other institutions around, and then we get to know you, and also the same with Lucy from Spain and other people that are here represented. And I think we strongly believe at the Geological Survey that the research must be collaborative. And this is an exercise that we have been doing with, for example, Sierra and AMS. It's a very good example on how a partnership can be built. Sometimes we host students that need a subject to work with, just like Marcela just finished her doctor. When she came to us, she was like looking for something to study on her PhD. And then we had a project in common, this Geneve, where she then figured in and she was able to have fun, to improve herself, and to finish a very nice PhD. This is a very nice example on how things should be. So last year, in the end of last year, we did a seminar about wetland in Uruguay, just like this, a volunteer based among friends, and we did it, and it made a lot of results. So right now we were called for reproducing the seminar in Bolivia and other places of Latin America. And sometimes a seminar like this one can change things in terms of how we believe research should be done. And to materialize this very interesting partnership with SEA, and because you guys here are hosting the seminar, we brought a very nice book on water. It's conflicts. It's a book. It's a photography book on conflicts about water.
So we can do a sorteio because you gave me one.
No, this is another
Yeah, another one.
This is conflicts in Brazil. I gave you the other one about in the world, but this is very nice done from a very good photographer, a Brazilian one, and we were able to tell him where to go, where the conflicts were going on, and he did a very nice job. And so this is the gift for the whole group. It's a very nice book to keep in the laboratory so that the people know exactly what they are doing research for promoting justice and bringing this country in a better shape. So this is for you. Yeah. Thanks a lot.
True. So I have so many thanks for all you that stay here during all day. And I would like to thank for Capo, for Sense, for the support for this seminar. I guess it's like it's a seed for a tree that is trying to grow. And I would like to thank also for the Geological Survey of Brazil for all the support in the Isotope program. To my students that really did a very good job organizing this seminar. And I think to finish, so isotopes teach me something very important that Roberto mentioned. So we are not too much people doing isotopes. And for this reason, I think that we should collaborate. And not exactly with running samples but discussing ideas as presented by Anna. So I guess this is important. So we have results. I participated in the committee of Anna. And I think this kind of collaboration makes me feel better, a better scientist, because I cannot do anything by myself or only in a small group of students. No, we have to share this information. And this kind of small workshop is a very good opportunity to have this exchange. I would like to thank everyone for being patient to stay here. And so we should take a picture. Yeah, for everyone here. If you can put the
Na frente do.
aqui na frente, né?
Só tira o.
Não, vou colocar o logo do seminário, né? Pronto.
Eles tinham bem lá no final esse.
Tá bom, de manhã eu faço coisas, tá? Aqui a gente já adorou. Ó,
Quem vai fazer a foto?
quem que é o cabelo senhor? X. Olha, quer que acende a luz na frente ou. Não sei. Talvez não. Tira assim e depois a gente tira um foto.
Boa, gostei do seu raciocínio. Muito bom.
Técnico em som, técnico em luz.
Vai derrubar, não.
Caberia todos. A gente pode.
Pode conseguir.
Sou técnica.
Valeu, Paulo.
João,